Hello, academic stars around the globe. Welcome to Caltex Academy. In case you're new, my name is Julius, and thank you for joining us today. On our board, we're looking at grade 12 trig identities, and in our previous video, we look at grade 11 with our summary in the sticker here. If you have not watched that video, I've left a link to the description of our video, or you can also check on the card up here and also watch that video in order for you to be familiar on how to use these two identities in questions. So today we're going to look at two more, and that is grade 12 identities with sine 2 theta and cos 2 theta. These are double angle identities. So for cos 2 theta, we have three expressions here. You can use it depending on how the question is asking you. And in this video, I'm going to walk you through 4 examples, and most of them are going to be proofs. So if you're excited, just like me, come closer and let's dive into the video to question number 1. Okay, for question number 1, we have it here. It says if theta is an acute angle and sine theta equals 0.6. Determine the value of sine 2 theta without using a calculator. And definitely, when you get this instruction without using calculator, your mind will be thinking of special angle. But for now, when we look at what we have here, we don't have the right angle here, but we have double angle. Then this will quickly refer to your grade 12 identities. And right away, I've just brought them near to our sticker here in order for us to be able to see or how to guide ourselves through the question. And the next thing we have to also do here is when we look at the question, it's saying acute angle. So this is an angle less than 90. Now, since sine is positive in the first and the second quadrant, then for it to be an acute angle, it must be in the first quadrant. And again, it's also good to show this in the Cartesian plane. But before that, we need to write sine theta as a fraction because the definition sine theta is given by opposite over hypotenuse. So let's copy our original question here. Sine theta is given by 0.6. Now when we reduce this down, we'll have 6 over 10. Now again, we can also go ahead and reduce this further. Therefore, sine of this angle theta can be expressed as 3 over 5 when we divide both the numerator and denominator by 2. And with that, we can go ahead and make a sketch of this in a Cartesian form and try to find out an expression for cosine since we have cosine somewhere here. Therefore, let's pick our axis here, and we know that we're working with the first quadrant, and we leave enough space for the first quadrant. And from here, we can have our line that makes the angle, and we also do the perpendicular down here. So let's adjust it so that it is a little bit okay. Now we need to show that it meets the x-axis at right angle. We do that. I think this is fair enough. And the next thing here, we need to have some leveling of this axis. So the horizontal axis is the x-axis and y is here. Now our angle theta should be here and is acute less than 90 degrees. So when you look at this, sine is given by opposite, and opposite from this triangle is 3. And the hypotenuse is 5, and this is our hypotenuse. Now since we're going to have this one as a cos, then cos works with adjacent and hypotenuse, and we need to put this adjacent here. Maybe we can say x. So x value here, we'll find it out after making this computation. So let's move on and have this written down. We have r square is given by x square plus y square. And since we're looking for the value for x, then we can make x the subject that we have here under root of r square minus y square. So let's make substitution, and this is Pythagoras theorem such that we have 5 here and 5 squared minus y is 3. We also square that, and then we square 5, we get 25, and if we square 3, we get 9 here. Subtracting 9 away from 25, we'll get 16. So we'll have a square root of 16, and square root of 16 is positive or negative 4. And since we're in the first quadrant, then the value for x is positive 4. Therefore, our x here is 4. We can either go ahead and get rid of this x here. And from there, we'll get back to our question and take a look exactly what the question wants us to do. The question is saying we need to find the value of sine 2 theta without using a calculator. Now from here, we can write sine of 2 theta following this identity, and we'll make substitution. So from here, we say our identity sine of 2 theta is given by twice sine of theta cos of theta. Remember, this is called double angle formula. And in double angle formula, if this is, for instance, 8 theta, then half of 8 will be 4. And since we have 2 theta here, then we have half of 2 is 1. And we have that. So we reduce it down, and we can now move on and make our substitution. So when we have 2 from our family, and we replace sine theta with the value of theta here, we substitute the theta around here, and it is 3 over 5. Closing up this bracket and multiplying with cos theta. So cos theta from our triangle here is adjacent over hypotenuse. So our adjacent is 4 and hypotenuse is 5. Now from here, we can move on and simplify. Therefore, multiplying the numbers in the bracket, we have 12. 12 times 2, we have 24. And from here, we multiply these denominators together and we obtain 25. So from here, sine of twice theta is the same as 24 over 25. And that is the solution for the first question. If you have not subscribed to the channel, go ahead and subscribe to the channel before we move on to question number 2. And if you have done that, thank you. Let's go ahead to question number 2. Yes, this is question number 2, and as usual, I've just got the sticker here together with the list of our identities for us to be able to guide ourselves. Now, question number 2 is saying, prove that sine x plus sine 2x over 1 plus cos x plus cos 2x is equals to tan x. And when you have this type of proof, what we have to do always is we look at the side that looks somehow complex, and we take that one for the proof to make sure that we continue simplifying to realize the simpler side. And the left-hand side looks a little bit complicated, and that is what we're going to consider for our work here. Remember, this is the left-hand side, and here is our right-hand side. So we take the one that looks somehow complicated and we work it through. Next year, we get is tan theta. So it's always good to bring what you are trying to look for near you, and it will also guide you. We know from our grade 11 identity, tan x is given by sine x over cos x. So for that case, after writing it here to you, then we copy our question down here where we're going to consider simplifying it. So we can say our left-hand side is equivalent to, we can start from the numerator, and that is sine x plus sine twice x. So we divide this by 1 plus cos x plus cos 2x. And our main aim is to obtain tan x. So from here, what we can do is to rewrite this into a form of double angle formula containing sine. So let's go and say the first one will be the same as sine x plus, this one is twice sine of x and cos of x. We're going to divide this by the expression here, also dividing this again to another form. So divide by 1 plus cos x plus. Now, before we rewrite this, we have to take precaution here Remember, our main aim is to say that we'll have cos at the denominator at the end of the day here, and we have sine at the numerator. Now, which of these expression will give us cos from the denominator? So we have two that has cos, the first one and the second one here. Now, definitely the first one has sine in it, so let's take the second one here, and we replace our cos 2x with. And let's move on and make that substitution, and that is how we normally make the choice. So we have here twice cos square x minus 1. And with that, you can see that this 1 plus 2 will cancel with this negative 1. And you can move on and write the remaining one, but also keep in mind that we need to factorize the common factor from the numerator here, and that is sine of x. So when we factor out, what we left here is 1 plus, we have here twice, and sine has moved out, we are left only with cos of x. And we can close our bracket here and we divide it. So our remaining denominator here, we can also factor out cos of x, and we're left inside here after factoring it out with 1 plus twice also cos of x. And you can see there's good news already here for us, since what is in the bracket is exactly the same. So it's going to cancel this bracket off, and I've left it only sine and cosine. So sine of our x divided by cos of x will give us tan as the right hand side. Therefore, we have tan x, and this is equivalent to the right hand side, since we considered the left hand side, and that is exactly how we can make the proof. We have selected the most complicated side and we simplified it down to something simple that looks like the right hand side. So if you're excited, smash that like button, subscribe to the channel, and share the video with friends. I know you have done it. Thank you. And let's move on to question number 3. Okay, for question number 3, it says that prove that 1 over sine 2 theta minus 1 over tan 2 theta is equal to tan theta. So let's also take the complicated part, and that's exactly the left-hand side, and we also do that proof. Now we can start right away here, and we say, considering the left-hand side, which is 1 over sine 2 theta minus 1 over tan 2 theta. Now we can go on and we rewrite our tan theta in terms of sine theta. Now from here, our left hand side, the first one, we need to maintain it the same, and we have sine 2 theta minus, so here we have 1 all over sine 2 theta over cos 2 theta. Now from here, we can write that, and we have, of course, we need to maintain the first term here, and we have still our 1 over sine 2 theta minus, so this one comes up, and we have cos 2 theta over sine also 2 theta. And the good news is sine is common from the denominator, and you can subtract the numerator. Therefore, we have here 1 minus cos of 2 theta, and we divide this by a common denominator, and that is sine 2 theta. As before in our example, remember we're working towards tan theta. So since we're going to have tan theta, and we know that tan theta is in terms of sine theta over cos theta, then we can say that the numerator we need sine to be the last thing here, and the denominator we need cosine. So what do we do in order for us to get this? So before we do that, we first need to replace this by the expression I've just marked here in order for us to see that it is in terms of sine and cos, but we need only cos to be remaining from the denominator. So let's move on and do that. Now, since we need sine from the numerator, we can also take this expression which contains sine. So 1 minus also this 1 here, and we need to have this in brackets because the whole of this is subtracted away from this 1, and we have it as minus 2 sine square theta. And after that, we divide this by, also replace this by 2 sine theta and also multiplied by cos theta. So after that, we can open up the bracket from the numerator and you can see that 1 is cancelling out because this is positive and we have here negative 1. So negative times negative, we get positive 2 sine square theta all over our 2 sine theta and cos also theta. Now when we cross out our 1, we're left here with only 2 sine theta square. So I'm going to split this into 2 and have twice sine theta, also another sine theta, and all over twice sine theta, that means cos theta. Now, why I split with this into 2 is sometimes I cross these 2 with the sign in the denominator, and somebody asked that how do you cross 2 and yet what we have here is sin theta. And normally if you have an expression like maybe a square, this a square means we multiply a by itself. So meaning these 2 here is telling us that we multiply sin theta by sin theta in order for us to see clearly that okay, one of the sin theta will cross with this sin theta and our 2 will also cross with this. Then we're left with only the remaining parameters here, and that is sine theta for the numerator and cos theta for the denominator. So let's write that, and I have this sine theta dividing cos theta. So when you divide them, you will simply get tan theta as the question demanded us to do, and this is equivalent to the right hand side. So you can also move on and check that indeed it is exactly what is required by the question, since the question says we need to prove that the left hand side equals the right hand side, and that is exactly what we have gotten. Then moving on very well, let us move on to question number 4. And question number 4 is the last one, very interesting. I hope you enjoy, and please give this video a thumbs up before we go to question number 4. Therefore, let's move on. Yeah, in question number 4, we have proof that tan 2 beta plus 1 over cos 2 beta equals sin beta plus cos beta over cos beta minus sin beta. Now, according to you, which of this side, the left hand side and the right hand side, looks complicated? In my own judgment, left hand side looks complicated because tan 2 beta is separate from here, so we have 2 terms from the left hand side, and yet here we have 1 term. So for this case, I'm going to take also my left hand side and continue finding out the right hand side. Now go ahead and also see if you can use the right hand side to obtain the left hand side. And once you do that, please come back and tell us in the comment section. And that is why I'm saying question number 4 is a little bit interesting and is unique. So with all this, we have already our formula sheet in our sticker here. We're going to use it for this. Looking at the last bit of this question here, the left hand side says tan 2 beta plus 1 over cos 2 beta. Now, how do you start solving this? Remember, we need to write this one in terms of sine and cosine always, and that is from our grade 11 identities. So we have here into 2 beta over cos of also 2 beta, and this is added to 1 over cos of 2 beta. Since our denominator is looking the same, we can go ahead and combine them to one term. Therefore, let us get more space here and have the numerator added such that we have sine 2 beta plus 1 all over 2 beta. Now from here, somebody will just start at what can I do next. Now, when we look at our identity from grade 11 again, which is this one here, we realize that 1 is given the same as the sum of sine square and cos square. So let's go ahead and replace this one with this exact expression here, and we'll see how it goes. So with all this said, let's implement what I've just mentioned here at our work. So sine of twice beta plus, instead of 1, we say sine square beta plus cos square beta is equals to this one here. And somebody start wondering, we have here 2 beta. Why have we got here beta and beta? Remember, if we use our identity up here, which says this one, the angle between theta has been reduced to half. So we're going to replace this with this side here and we'll obtain the angle as 1. So let's move on and also do something for the denominator. Now, before we do something for the denominator, remember we're gonna have 2 things from the denominator here, that is sine and cosine, since we are asked to prove that we have 2 terms in the denominator, cos beta and sin beta. So when you look at this cos 2 theta is given by the first expression contains cos and sin. So we're going to use this one for our question here. So let's move on and implement that from the denominator and say, okay, instead of writing cos 2 beta, we're going to write cos square beta minus sine square also beta. Now when you look at also the numerator here, we need to replace that and take a look at the denominator also again. We have difference of 2 squares here, so we're going to replace that. The first term from the numerator becomes twice sine of a single beta here now, and cos of also the same beta as our sine square beta plus cos square beta. Now we also divide this by this denominator, and remember our denominator here we're writing in terms of difference of 2 squares, where we have the first term here. We're going to create a different bracket here, and this is the first bracket, and our second bracket begins from here there. So let's bring in what's inside this difference of 2 squares. So we take one of these cos and we bring it inside here, cos beta, and we subtract the second parameter is sine beta, and here we add the 2 parameters also. Now once we have done that, the numerator looks somehow complex. But if you take a closer look at this numerator, you realize that, okay, when you have an expression of this type, now when you rewrite that, we can notice something from what we have written here. When you look at here, we have 2, we also have 2 here. Now with that, you can conclude that, okay, our sine is corresponding to A, then our cos is corresponding to B. Now if that is the case, replacing this with sine and cos will have the expression, the numerator reduced into this parameter. I hope we're all together up to this time. I will not confuse anybody. In case you have a question, please do it in the comment section. I will come back and clarify you. When we replace A with our sine beta and we replace B with cos beta, then this expression would be like sine beta plus cos beta, like that, and it is squared. So we're going to replace the whole of this one with this expression here. So with that, we may erase this before we continue working. The numerator therefore becomes sine beta plus cos beta. I think it's good to have them all in bracket. The whole thing is also squared, and we divide this by the denominator in these brackets we put it earlier on, and let's first replace them there. Cos beta minus sine beta, and we have here cos beta plus sine beta. So we can see that this expression is looking like one of these. The only difference here is we are starting here with the cos and followed in by sine. Meanwhile, we have here sine followed in by cos. When you have a number like maybe 2 plus 3, your result is 5. And we interchange here 3 plus 2, still you can get 5. So switching on the cos and sine will not affect our work. And because of that, let us rewrite our expression from the denominator in the same format in order for us to be able to see that they are really looking the same, and we can cancel them away. Therefore, the expression from the numerator, we can rewrite it as, let's maintain this same bracket here, and we have 2 of them, dividing it with the denominator with these packages also. So we're going to fill in these packages with sine of beta plus cos of beta and sine of beta plus cos of beta. Then down here we can write this, that is cos of beta minus sine of beta. And in order for this to look exactly like what we have in the numerator, we can start with sine of beta plus cos of beta. And from here, you can now see that we can cancel one of this bracket with this one here, and we're only left with this remaining parameters, and that is equivalent to the right hand side of the expression. Let's take a look once more to see that exactly they look the same. So when you look at our question here, we have sine beta plus cos beta over cos beta minus sine beta, and indeed they agreed with our solution here, sine beta plus cos beta over cos beta minus sine beta. So as I mentioned earlier on, also go ahead and take the right hand side, try to work it out to see if you can obtain the left hand side. Thank you very much for watching up to this time, and see you in our next video where we're going to discuss about reduction identities. See you in that video. Peace out.